What is digital signal processor, working and its applications? The processor is a simple chip or logic circuit that responds to basic instructions as well as input processes to control the processing unit. The processor is an essential component in electronic systems like smartphones, embedded systems, laptops, computers, etc. The two essential components of a processor are ALU and the control unit. There are different types of processors available in the market which is used based on the requirement like microcontroller, microprocessor, digital signal processor, embedded processor, etc. What is a digital signal processor? Digital signal processor definition is, a digital signal processor is a special type of microprocessor which is fabricated on metal oxide semiconductor integrated circuits. DSPs are extensively used in different applications like digital image processing, telecommunications, audio signal processing, speech recognition systems, sonar, radar, etc., and also used in consumer electronics like mobile phones, HDTV, high-definition television, products, disk drives, etc. How does digital signal processor work? The digital signal processor mainly works by using real-world signals like audio, voice, temperature, and video, digitizing them and after that mathematically manipulating them. A DSP performs different mathematical functions very quickly like add, subtract, multiply and divide. A digital signal processor includes main components like program memory, data memory, compute engine, and input-output. Program memory is used to store the programs to process data. Data memory is used to store the data to be processed. Compute engine executes the mathematical operations, access the data from the data memory and program from the program memory. Input-output serves different functions to connect to the external world. Digital signal processor block diagram. The block diagram of the digital signal processor is shown below. In the above block diagram, a microphone is used as a transducer which changes the sound signal into an electrical signal. After that, an analog electrical signal which is generated from a microphone is given to an op-amp to condition the analog signal. An anti-aliasing filter is an LPF, low-pass filter, that is located on the input of an ADC. This filter is used to band-limit wideband signals. After that, a simple ADC converter unit uses analog signals and outputs as binary digits streams. In this block diagram, the DSP is the heart of the system. At present, CMOS ICs are used to make DSPs that have high data throughputs, dedicated instruction sets and high speed. After that, DAC converts digital to an analog signal. The smoothing filter is another LPF used to smoothen the output by eliminating unnecessary high-frequency components. Here, a speaker is the output transducer. So you can utilize anything else based on your requirements. Features. The features of digital signal processing include the following. Digital signal processors are mainly designed for supporting repetitive and numerically intensive tasks. Most digital signal processors include a powerful data path and also the capacity to move large amounts of data to memory quickly. These processors provide unique instruction sets to develop the efficiency of hardware. The two significant features of digital signal processors are the data path including multiple access memory architectures and fast multiply accumulate units. Pipelining is frequently used to enhance the processor's performance. So at present, most processors use pipelining, but in the development of enhancing performance, pipelining will make programming very hard. Characteristics. The characteristics of a digital signal processor include the following. DSPs can provide the best performance. The memory which is used to store a program is different as compared to memory used to store data. DSPs don't provide multitasking supported hardware. Special instructions are there for modulo and reversed bit addressing. This processor can be used as a DMA, direct memory access, device in the host or supporting situations. DSPs include specially designed architecture to fetch multiple data. Generally, the DSPs include architecture to optimize different features like the following. Special hardware is used to carry looping at less cost. The multipliers or accumulators that are available are extremely parallel. A unit handles floating numbers within the data flow path directly. The calculations are usually carried out by a fixed-point arithmetic process to speed them up. Most of the registers present in computers today move the data to the lowermost bit if an overflow occurs. However, in digital signal processors, the overflow is retained at the maximum point itself. Digital signal processor architecture. The architectures of the digital signal processors are: 1. Neumann architecture, Harvard architecture, Super Harvard architecture. 1. Neumann architecture. 1. Neumann's architecture of a digital signal processor mainly includes a single memory and a single bus which are used for data transferring into and out of the CPU, central processing unit. Multiplying any two numbers needs at least 3 CLK cycles, where 1 CLK cycle is used to transmit each of the 3 numbers from the memory to the CPU with the help of the bus. We don't calculate the time taken to transmit the output back to memory, as we assume that it will stay within the central processing unit for extra manipulation. This type of architecture is quite suitable when you are satisfied to perform all of the necessary tasks in serial. At present, most computers use 1 Neumann architecture, but other architectures simply need where very fast processing is necessary. Harvard architecture. The name of Harvard architecture is taken for the work finished at Harvard University in the year the 1940s under the Howard Aiken leadership. As shown in this design, it includes to separate memories for both the data and program instructions, including separate buses for each. When the buses work independently, then data and program instructions can be fetched together to improve the speed over the single bus. At present, this dual bus architecture is used by DSPs. Super Harvard architecture. The Super Harvard architecture of DSP is shown below. This name was coined through analog devices to explain the internal function of their new ADSP 211XX and ADSP 2106X families of DSPs, which are called Shark DSP, which is a reduction of the longer term of Super Harvard architecture. This architecture was implemented by including some features to increase the throughput. While the Super Harvard architecture digital signal processors are optimized in several methods, two areas are significant enough to be included, like an instruction cache and an I/O controller. Types of digital signal processor. Digital signal processors are available in two types: fixed-point processors and floating-point processors. Fixed-point digital signal processor. In a fixed-point digital signal processor, every number can be specified through a minimum of 16 bits, even though a different length can be utilized. The number can be represented with different patterns. The fixed point means that the fractional point position can be assumed to be fixed and to be identical for the operands as well as the operation result. Fixed-point processors are used in different flexible embedded applications because it uses low power and less cost. The fixed-point digital signal processor are TI's trademark 320C54X, are the DSP BF53X, trademark 320C55X, trademark 320C64X, trademark 320C62X and Motorola MSC810X. Floating point digital signal processor. Floating point digital signal processors mainly use a minimum of 32 bits to store every value. The distinct feature of floating point DSP is that the signified numbers are not spaced uniformly. Floating point digital signal processors can simply process the fixed point numbers, a requirement to implement counters and signals which are received from the analog to digital converter and transmitted to the digital to analog converter. For both the operations of fixed point and floating point DSPs, Shark DSPs are simply designed, optimized and executed with equivalent efficiency. As compared to fixed point DSPs, the programs of floating point DSPs are simple. However, they are normally very expensive and power consumption is also more. The types of floating point DSPs are TI's TMS 320C67X and ADI ADSP 2116X 2126X. Digital Signal Processor Instruction Sets. The TMS 320FC24X DSP assembly language instructions are discussed below. These instruction sets simply support numerically intensive signal processing operations and general-purpose applications like high-speed control and multiprocessing. The instruction set of C24X is well suited with the C2X instruction set because code written for the C2X is recollected to run on the C24X. The instruction set of TMS 320FC24X DSP is given below. Accumulator, arithmetic and logic instructions. Auxiliary register and data page pointer instructions. PREG, PREG and multiply instructions. Branch instructions. Control instructions. I/O and memory operations. The arrangement of each instruction can be done alphabetically. Here, the know of words that an instruction occupies within program memory and also the know of cycles that instruction needs to perform are specified. All these instructions are assumed to be performed from internal data dual-axis memory and internal program memory. DSP memory architecture. For memory management, conventional DSPs use von Neumann architecture where equal memory is utilized to store both the data and program. Even though this simple architecture uses a number of processor cycles to execute a single instruction because the same bus is utilized for both program and data. In order to enhance the operation speed, separate memories were utilized to store both the program and data. A separate set of address and data buses are provided to both memories, so this architecture is known as Harvard architecture. Even though the separate memories utilization for data and the instruction will increase the processing, it will not solve the problem totally. Because many DSP instructions need above one operand, utilization of single data memory can lead to getting the operands continuously, so processing delay will be increased. This issue can be solved with two separate data memories to store operands individually. Therefore, in a single CLK cycle, both the operands can be simply fetched mutually. Even though the above architecture enhances the operation speed, it needs more hardware and interconnections, and the complexity and cost of the system can be increased. As a result, there should be an exchange between the speed and cost when choosing the memory architecture of a digital signal processor. Difference between digital signal processor and microprocessor. Digital signal processor. It is a specialized microprocessor chip. DSPs are extensively used in telecommunications, audio signal processing, digital image processing, etc. In DSP, instruction can be simply executed in a single CLK cycle. Parallel execution can be achievable. DSP is suitable for the operation of array processing. Addressing modes used in this processor are direct and indirect. Address generation can be possible by combining program sequencers and DAGs. It includes 3 separate computational units, MAC, ALU and shifter. The program flow can be controlled by an instruction register and program sequencer. It includes separate data and program memories. In DSP, several operands are fetched at once. In DSP, address and data bus are multiplexed. Microprocessor. It is a computer processor. Microprocessors are used in PCs for text editing, computation, multimedia display and communication over the Internet. The microprocessor uses several clock cycles for one instruction execution. Sequential execution is possible. It is suitable for general-purpose processing. Addressing modes used in microprocessors are direct, immediate, register indirect, indirect register, etc. The program counter or PC can be incremented to produce an address sequentially. It includes simply the main unit like ALU. Program counter can control the execution flow. It doesn't have separate memories. In a microprocessor, the operand can be fetched serially. In a microprocessor, address and data bus are not multiplexed. Advantages. The advantages of a digital signal processor include the following. Overall noise is less. Possibility of error detection and correction. Simple data storage. Digital signals are simple to encrypt. Transmission of more data is possible. In digital processing systems, modifying a few commands otherwise change a few code lines is easy to modify. DSP systems work through a broader range of frequencies. In a digital system, the DSP can be cascaded without any loading issues. The operations of DSP can be simply changed by altering the program within a digital programmable system. By using the DSP method, a complicated signal processing algorithm can be simply implemented. DSPs are lightweight and more compact. DSP systems are upgradable because they are controlled by software. Disadvantages. The disadvantages of a digital signal processor include the following. Digital communications need high bandwidth to transmit the data as compared to analog. Most of the digital signal processors are expensive. The DSP system complexity will be increased due to the usage of additional components. Digital signal processor uses several transistors which consume more power as compared to analog signal processors. The hardware architecture and software instructions of each DSP are different, so required highly skilled engineers to program the device. Applications. The applications of a digital signal processor include the following. DSP applications mainly include processing of audio and speech, radar, sonar and other sensor array processing, statistical signal processing, spectral density estimation, data compression, digital image processing, audio coding, video coding, image compression, signal processing for control systems, telecommunications, seismology, biomedical engineering, etc. Thus, a digital signal processor is a specialized microprocessor. The main function of this processor is to measure and compressor filter analog signals. Usually, digital signal processors have better power efficiency, so they are mostly used in portable devices like mobile phones due to power utilization constraints. These processors frequently use special memory architectures to fetch multiple data, otherwise instructions simultaneously. Here is a question for you. What is digital signal processing?